Hello viewers, welcome to CSCIT Objective Channel. CSCIT Objective Channel আপনাকে স্বাগত. Today we will discuss about computer architecture and organization. Computer organization এবং architecture এই সাবজেক্টে আজকে আমরা কতগুলো বিষয় নিয়ে আলোচনা করব তোমাদের সাথে. পয়েন্টগুলো হচ্ছে what is computer architecture and organization, central processing unit CPU, arithmetic logic unit, control unit, memory register, internal communication of CPU, CPU to memory communication, and CPU to IO device communication. চলো শুরু করা যাক. প্রথম যে টপিকটা সেটা হচ্ছে what is computer architecture and organization. Computer architecture is the design or the logical structure of a computer system, while computer organization is how the design and physical arrangement of various hardware units of a computer system are connected. Computer architecture describes how the computer system is designed. It defines what the computer interface displays, specifies how the hardware and software components connect and interact. Computer architecture defines how the computer stores data, processes instructions, and performs operations. Now is computer organizations. It describes how the operational parts of a computer system are linked together. Computer organization explains how the computer works. It deals with the physical components of a computer system such as CPU, memory, and input-output devices. Now we will discuss about Central Processing Unit or CPU of the computer system. What is Central Processing Unit? What is CPU? Why the CPU is called the brain of the computer? What are the functions of the CPU? The CPU, which is popularly referred to as brain of the computer, is responsible for processing the data inside the computer system. It is also responsible for controlling all other components of the system. Figure 1 shows a typical block diagram of the computer system, illustrating the arrangement of CPU with the input-output units as well as the memory of the computer system. Figure 1 shows the block diagram of a computer system. Input data sends the data to the CPU, which is consist of registers, arithmetic unit, logic unit, and control unit. In the time of execution, in the CPU, the data and instruction are executed and store and retrieves data and instruction to and from memory unit. And after execution, the data and instruction receives a results as output through output devices or units. The main operation of the CPU include 4 phases. Fetching, first of all, fetching instruction from the memory Second is decoding the instruction to decide what operation to be performed. Third is executing the instructions. And fourth and finally is the storing the results back in the memory. These are the four main operations of CPU. The four-phase process is known as the CPU cycle, which is illustrated in the figure 2. As shown in that figure 1, the central processing unit consists of the following subsystems. First is arithmetic units, second is logic unit, and third one is control unit. The CPU makes use of the following memory subsystem for carrying out its processing operations. The CPU makes use of the following memory subsystem for carrying out its processing operations. First, main memory unit, second is cache memory, third is registers. The figure 2 shows the CPU cycle. Arithmetic unit, logic unit, control units. What is arithmetic unit and how AU performed? Arithmetic unit is a part of the CPU that performs arithmetic operations on the data. The arithmetic operations can be addition, subtraction, multiplication, and division. Arithmetic unit takes the input in the form of an instruction that contains the opcode, operands, and the format code. The opcode specifies the operation to be performed, and the operands specify the data on which is to be performed. The operation on which operation the format code suggests the format of the operand, such as fixed point or floating point. The output of arithmetic unit contains the result of the operation and the status of the result. Whether it is final or not, the output is stored in a storage register by the AU. What is register? Register is a small storage area inside the CPU from where data is retrieved faster than any other storage area. So, the register is a small storage area inside the CPU from where data is retrieved faster than any other storage area. What is logic unit and performed? Logic unit is a part of the CPU that performs logical operations on the data. It performs 16 different types of logical operations. The various logical operations include greater than, less than, equal to, not equal to, shift left, shift right, and etc. Logic unit makes use of various logic gates such as AND, OR, NOR, etc. for performing the logical operations on the data. What is control units? How it is performed? Control unit is an important component of the CPU that controls the flow of data and information. It maintains the sequence of operations being performed by the CPU. It fetches an instruction from the storage area, decodes the instruction, and transmits the corresponding signal to the AU or LU and the storage registers. And the storage registers CU guides the AU and LU about the operations that are to be performed and also suggests the input-output devices to which the data is to be communicated. CU control unit uses a program counter register for retrieving the next instruction that is to be executed. It also uses a status register for handling conditions such as overflow of data. What is RAM? What is the function of it? What is swapping? The main memory is referred to as the internal memory or primary memory of the CPU. It is also known as the random access memory or RAM. The main memory is referred to as the internal memory or primary memory of the computer. It, it is also known as random access memory. It is a temporary storage medium that holds the data only for a short period of time. Once the computer is switched off, the data stored in the RAM gets erased. The memory space of RAM is limited, and therefore all the files and instructions cannot be stored in it. These files and instructions are normally stored in a different location that is known as secondary storage and are copied from where to be RAM to the RAM before execution. The technique is referred to as swapping. The memory space available in RAM also affects the speed of computer system. If the memory space is more number of instructions can be copied and executed at the same time. As a result, the computer system need not read the data from the secondary storage again and again, thus making the processing faster. The main memory is also responsible for holding intermediate data transferred between the CPU and the I/O devices. What is cache memory and how it is performed? Where is it is located in the computer system? What are the types of cache memory? Cache memory is a small, fast, and expensive memory that stores the copies of data that need to be accessed frequently from the memory. The processor, before reading data from or writing data to the main memory, checks for the same data in the cache memory. If it finds the data in the cache memory, the processor reads the data from or writes the data to the cache itself because its access time is much faster than the main memory. The cache memory is always placed between the CPU and the main memory of the computer system, as shown in Figure 3. Figure 3 shows the cache memory. First of all is the main memory and cache memory and processor. So processor or CPU is communicate with the main memory through cache memory. Figure 3 shows the data fast transfer of data between the processor and the cache memory is bidirectional. Figure 3 shows that the transfer of data between the processor and main memory between the processor and cache memory is bidirectional. The availability of data in the cache memory is known as the cache hit. The capability of a cache memory is measured on the basis of cache hit. There are usually two types of cache memory found in the computer system. First of all is primary cache, second is secondary cache. Primary cache, it is also known as the level 1 or L1 cache or internal cache. The primary cache is located inside the CPU. It is smaller but faster type of cache that provides a quick access to the frequently accessed data by the microprocessor. Secondary cache, it is also known as the level 2 or L2 cache or external cache. The secondary cache is located outside the CPU. It is normally positioned on the motherboard of a computer. The secondary cache is larger but slower than the primary cache. Now we will discuss about memory register. What is a register in the computer systems? How many registers are in a CPU? How does it works? A register is a small fast storage space in a computer CPU that temporarily holds the data and instructions. Registers are also known as memory registers. A processor can have different types of registers to hold different types of information. There includes: first is program counter, to keep track of the next instruction to be executed. Second one is instruction registers, IR, to hold instruction to be decoded by the control unit. Third one is memory address registers, MAR, to hold the address of the next location in the memory to be accessed. Fourth one is memory buffer register, MBR, for storing data received from or sent to CPU. Memory data register, for storing operations and data. Accumulator register, accumulator, for storing the results produced by the arithmetic and logic units. An effective implementation of registers can increase considerably the speed of the processor. Internal communications of the CPU. First is internal communication of the CPU, which unit of the computer system communicates with the memory and the I/O devices in order to transfer data between them. Answer is Central Processing Unit or CPU. What is the internal communication of CPU? In the computer system, what are the types of internal communications? The internal communication within a CPU happens through a system of buses, which are essentially electrical pathways that carry data, addresses, and control signals between different components like the arithmetic logic unit, control unit, and registers, allowing them to exchange information and execute instruction efficiently. This is often referred to as the internal bus or local bus within the CPU. CPU of the computer system communicates with the memory and input-output devices in order to transfer data between them. However, the method of communication of CPU with memory and input-output devices is different. The CPU may communicate with the memory either directly or through the cache memory. The CPU may communicate with the memory either directly or through the cache memory. Therefore, the internal communication of a processor in the computer system can be divided into two major categories. First is processor to memory communication and processor to input-output device communication. Now we will discuss about the processor to memory communication. The direct communication between the processor and memory of the computer system is implemented with the help of two registers. They are memory address registers and memory buffer registers. The processor can interact with the memory of the computer system for reading data from the memory as well as for writing data on onto the memory. The MAR and MBR registers, memory address registers and memory buffer registers, play a very important role in implementing this type of communications. These registers are the special purpose registers for the processor. Memory address register is used by the processor to keep track of memory location where it needs to be performed the reading or writing operations. This register actually holds the address of the memory location. On the other hand, the memory data registers is used by the processor to store the data that need to be transferred from or to the memory of the computer system. The reading and writing operations performed by the processor are called memory read and memory write operations. Figure 5 illustrates the memory read operations performed by the processor of the computer system. The processor performs the following steps to read the data from the desired memory locations. First, the processor loads the address of the memory location from where data is to be read into the memory address registers using the address bus. First, the processor loads the address of the memory locations from where data is to be read into the memory address registers using the address bus. After loading the addressing the memory locations, the processor issues the read control signal through the control bus. The control bus is used to carry the commands issued by the processor, and the status signals are generated by the various devices in response to these commands. After receiving the read control signal, the memory loads the data into the memory data registers from the location specified in the memory address register using the data bus. Finally, the data is transferred to the processor. The memory write operations. The memory write operations helps the processor to write the data at the desired memory location. Figure 6 illustrates the memory write operations performed by the processor of the computer system. Figure 6 illustrating the memory write operations. The processor performs the following steps for writing the data at the desired memory location in the computer system. First of all, the processor loads the address of the memory locations where data is to be written in the memory address registers using the address bus. After loading the address of the memory location, the processor loads the desired data in the MDR register using the data bus. After this, the processor issues the write control signals to the memory using the control bus. After this, the processor issues the write control signal to the memory using the control bus. Finally, the memory stores the data located in the MDR register at the desired memory locations. Finally, the memory stores the data loaded in the MDR register at the desired memory locations. So, so the memory write operations. Processor to input output device communications. processor to input-output device communication, what is interface unit and device controller? The communication between input-output devices and processor of the computer system is implemented using an interface unit. The interface unit acts as an intermediary between the processor and the device controller of various peripheral devices in the computer system. The basic function of the interface units is to accept the control commands from the processor and interpret the commands so that they can be easily understood by the device controllers for carrying out necessary operations. Therefore, we can say that the interface unit is responsible for controlling the input and output operations between the processor and the input-output devices. Therefore, we can say that the interface unit is responsible for controlling the input and output operations between the processor and the input-output devices. In a computer system, data is transferred from an input device to the processor and from the processor to an output device. Each input and output device in the computer system is provided with a controller that is called device controller. The device controller is used to manage the working various peripheral devices. The processor actually communicates with the device controller of the various input-output devices for performing the input-output operations. Communication process between the processor and input-output devices. Figure 7 illustrating the communication process between the processor and device controller. Next is input-output read operations. Figure 8 illustrates how the data is transferred from an input device to the processor of the computer system. Input-output write operation. Figure 8 illustrating the input-output read operation and Figure 9 illustrating the I/O write operations. What is I/O write operations? Figure 9 illustrates how the data is transformed from the processor to an output device. Figure 8 illustrating the I/O write operations and Figure 9 illustrating the I/O write operations. Thanks for watching. Rest of the part of the computer organization and architecture we will explain in the next videos. To get the videos available, please subscribe to the channel and click on bell icon for notification. Stay with us. Thank you. Subscribe to the channel. You please subscribe to the channel that you like in order to see more content from our channel. You can find a subscribe button under any YouTube video or on the channel's once you subscribe to the channel and a new videos that we will publish will be displayed in your subscription feed. You may also start receiving notifications where the channel that you subscribe to publishes new content. If you like our videos, please click on the like button, comment text if you wish, and share videos with others to get motivation for creating more unique videos. So thank you very much. সো পরবর্তী আরো অনেক ভিডিও পাওয়ার জন্য আপনারা প্লিজ সাবস্ক্রাইব টু দ্য চ্যানেল। চ্যানেলটিকে সাবস্ক্রাইব করুন এবং আরো অনেক নতুন ভিডিও নিয়ে তোমাদের সামনে উপস্থিত হব নতুন নতুন কন্টেন্ট নিয়ে। সো থ্যাংক ইউ ভেরি মাচ। আপনারা সবাই ভালো থাকবেন, সুস্থ থাকবেন।